Hey everyone, welcome to another deep dive. This time we're taking a look at your research on polymorphism in Java. It looks like you've been digging into payment systems, which is super interesting, and I'm excited to kind of break it all down with you.
Yeah,
I'd have to say, polymorphism always sounds kind of intimidating,
right.
but I have a feeling it's going to be one of those concepts. It's like, oh, okay, once we, really get into it.
Yeah, I think so too.
So to get us started, could you maybe give us like a simple explanation of what exactly polymorphism is?
Sure. So, polymorphism, I think the best place to start is with the word itself. Polymorphism comes from the Greek words poly and morph, meaning many, and forms. So, we're essentially talking about the ability of things to take on many forms. In Java, that looks like objects being able to behave differently depending on the context.
Okay, I'm kind of intrigued now. But how does that idea of like many forms actually like play out in Java programming? And what does that have to do with payment systems?
Well, let's think about that payment system example that you provided.
Yeah.
So you have this one action, right? Making a payment. But the way that you make that payment can take many forms.
Right.
You could use a credit card, a debit card, a digital wallet. So all of these different methods, they all have their own unique process. Even though the end goal is the same, you're trying to make a payment.
Right. So it's like I'm telling the system make a payment, but I'm not being specific about how to make the payment. That's where polymorphism comes in.
Exactly. It lets the system figure out the how based on what payment type you were trying to use. It's kind of like ordering a pizza. You might choose different toppings, but ultimately you're still ordering a pizza.
Okay, I like that. So how does Java actually handle all these different forms of payment? Does it have some kind of secret code or something?
Yeah, so it's not exactly a secret code, but it has these two main ways that it handles this, and it's called compile time polymorphism and runtime polymorphism.
Okay, those sound kind of complicated.
Yeah.
So let's unpack those. Let's start with compile time polymorphism. What is that all about?
So compile time polymorphism, this is also known as method overloading.
Cool.
And what this lets you do is have multiple methods in a class with the same name, but different parameter lists. So think of a parameter list like a list of ingredients that your method needs to work with.
Okay.
So in the payment system example, if you have a method called process payment, for a credit card payment, that might need a credit card number and an expiry date, whereas if you're doing a digital wallet payment, that might just need a wallet ID.
So it's like the same method name, process payment, but different sets of instructions depending on what type of payment I'm making.
Yes, exactly.
Does Java just like magically know which instructions to follow?
Not magic, but pretty close. The compiler, which is the part of Java that translates your code into something the computer can understand, it's clever enough to figure out which process payment method to call based on those ingredients that you provide, those parameters that we talked about.
Got it. So if I give it credit card info, it uses the credit card instructions.
Exactly.
If I give it a wallet ID, it knows to use the wallet instructions. That makes sense.
Yeah.
But what about runtime polymorphism? When does that come into play?
So runtime polymorphism, this is also called method overriding, and this is all about inheritance. So imagine you have a base class called payment.
Okay.
And this class has a method called process payment. And then you have these subclasses like credit card payment and wallet payment, and those inherit from that base class. And now each subclass can provide its own specific implementation of that process payment method tailored to its own needs.
Hold on. Wouldn't it make sense for Java to just know which method to use based on what I'm trying to get back, like a string or an integer?
That's a really great question. And that brings up an interesting point about how Java works. While it might seem logical to choose the method based on what you want to get back, Java actually needs a way to tell the difference between methods while it's compiling your code. So that distinction is based on the method's name and what's in the parameter list. We call that the method signature.
Okay.
And the return type alone isn't quite enough information for the compiler to know which method it should use.
So it can't just be like, okay, I want this back, so I'm going to use this one. It needs more info.
Exactly. It's almost like if you were ordering food at a restaurant.
Okay.
If you just said, like, I want a dish with chicken, that's not really enough information.
Right.
They need to know which chicken dish you want.
Okay, so the return type is like saying, I want a chicken dish.
Right.
But the parameter list is like, okay, I want, chicken parmesan or whatever.
Yeah, exactly. That's a great way to put it.
Okay, that makes a lot more sense.
Yeah.
Okay, going back to runtime polymorphism,
Yeah.
then are you saying that like each payment type can have its own way of handling the process payment action, even though they all share that same basic method name?
Yeah, exactly. And what's really cool about this is that the decision of which process payment version to use is made while the program is actually running. Wow. It figures it out based on what kind of payment object it's dealing with at that time. And we use this special thing called an annotation, the @override annotation, to let the compiler know that this is happening.
So if I'm understanding this right, I can use that same process payment command for any kind of payment, and the system just figures out the details on its own.
Yeah.
That seems really useful.
Yeah, it definitely can be.
So can we see an example of how all of this actually works in practice?
Absolutely. So let's take a look at the e-commerce platform code that you sent over. In the code, you'll notice that a payment object can be used to represent different payment types. So it could be a credit card payment or it could be a wallet payment.
Okay.
And when you call the process payment method on that object,
The system picks the right version based on whether it's a credit card or a wallet.
you got it.
Okay, so now I'm really starting to see like how powerful polymorphism is and how this could be used in real applications. This is awesome. But before we kind of get too far ahead of ourselves with all the cool stuff we can do with this, I just want to make sure I'm not missing anything about like the core concepts of those two types of polymorphism.
That's a good idea. Let's do a quick recap.
Yeah, let's recap. So compile time polymorphism, also known as method overloading, is like having a bunch of different recipes for the same dish.
Right.
Like you can make pizza with a bunch of different toppings, but it's still pizza.
Right.
And the compiler just knows which recipe to use based on the ingredients, the parameters that you give it.
That's a perfect analogy.
And runtime polymorphism, which is method overriding, is like having that base recipe for the pizza. And then you can customize it, right?
Yeah.
So you could have your deep dish Chicago style or your thin crust New York style, all these variations. And the system figures out which variation to use while the program is running based on what specific type of pizza object it's working with.
Exactly. You're getting this so quickly. And what's so cool is that this whole idea of flexibility, it doesn't just apply to pizzas or payments. Polymorphism is such a useful tool that it can be used for so many things in programming.
Okay, now I'm like really curious. But before we like go crazy with all the possibilities, are there any tricky parts about using polymorphism? Any like common mistakes that people make that we should be aware of?
Yeah, that's a great question. A really common mistake that I see a lot of developers make is that they try to overload methods based only on the return type.
Okay.
And remember we were talking about the method signature, the method's name and the parameter list?
Right.
Well, the return type isn't actually part of that signature.
So if I had two methods that had this same name and the same parameters, but one returned like a string, like a confirmation message, and the other one returned an integer, like a payment amount, that would be a problem.
Yeah, that would definitely cause some issues. And actually, if we look at that card payment system example that you provided, initially it had two process payment methods, both of which took a single string as a parameter, which represented the card number. And one of them was designed to return a confirmation message, that was the string one, and the other one was supposed to return a fixed payment amount, so that was the integer.
I wonder why that doesn't work. It seems like that would make sense. Like if I want a message back, I would use the string version. If I want the amount, I would use the integer version.
Yeah, I can totally see why you would think that, but the compiler needs a really clear way to tell the difference between the different methods at compile time.
Okay.
And remember that differentiation is based on the method signature.
Right. So I can't just rely on what I want back. I have to give them different names or different parameters so that the compiler knows exactly which one to use.
You got it.
So how did you fix this problem then in the card payment example?
So in the corrected code, you'll see that there are now 3 process payment methods, each with a different parameter list. So one of them takes just the card number, another one takes the card number and the payment amount, and then the last one actually takes an array of card numbers.
Okay.
So by changing those parameters, we're creating unique method signatures, which means that the compiler can tell them apart.
Got it. So each process payment method now has a very specific purpose, and the compiler can tell the difference just based on what information I give it.
Exactly.
This is making way more sense now.
Yeah.
But I'm still kind of wondering, like, why is polymorphism such a big deal in programming? We've talked about payment systems a lot, but you mentioned that this concept has much broader applications. So, like, why should I care about this? What are the benefits that I'm going to see when I actually use this?
That is a great question. And that brings us to the heart of why polymorphism is considered so powerful when we talk about object-oriented programming. So one of the key benefits is flexibility. So for example, let's say you needed to add a new payment method to your e-commerce platform, like a UPI payment. With polymorphism, you can just create a new subclass for that UPI payment, and you can implement the logic for process payment without having to change any of the existing code.
Whoa, so I wouldn't have to go back and like rewrite a ton of code just to make it work with this new payment method.
Exactly.
That'd be amazing.
Yeah, it can save you a lot of time and headaches. Polymorphism just makes your code so adaptable and able to change when you need it to. And that's so important these days when technology is constantly changing. You always have to be ready for something new.
Okay, flexibility is definitely a huge plus. What other advantages should I know about?
Another big one is reusability.
Okay.
So with inheritance and method overriding, you can actually define all of that core functionality in that parent class and then just reuse that code over and over again in all the subclasses. And each subclass can tweak that behavior as needed.
Boy.
So that way you don't have to repeat code all over the place.
So it's like I have this like blueprint that I can customize for different things without having to start from scratch every time.
Exactly. It can make your code a lot more organized and easier to work with.
That sounds amazing.
Yeah. And then finally, polymorphism also makes your code more scalable.
Okay.
So as your application gets bigger and you need to add new features, polymorphism makes it really easy to do that. You can just add new subclasses, you can override the methods, and you can just keep expanding your code without having to rewrite stuff and break things that are already working.
So it's not just about handling all the different ways to pay right now, but it's about making sure that your system is ready for whatever payment methods come out in the future.
Yeah, that's a great way to think about it.
Seems like polymorphism is really important if you want to build systems that are going to last.
It definitely is. And remember we talked about how polymorphism basically means that objects can take on many forms? Well, that concept can be used for all kinds of things, not just payment systems. Think about like video games. You could have a base class for enemy, and then you could make subclasses for like all the different kinds of enemies.
Okay.
And each one could have its own special attacks or ways of moving around, all thanks to polymorphism.
So like one enemy could be like super fast.
Right.
And another one could be like really strong but slow.
Exactly.
I like it.
Or think about like a graphics engine, you know, the kind that makes all the visuals work in software. You could use polymorphism to define different shapes, so like circles, squares, triangles, all of that. And each one could have its own way of drawing itself.
So I could just say draw, and it would know to draw the right shape depending on what type of shape it was.
Exactly.
That's pretty cool.
Yeah, and that would let you create all kinds of complicated images without having to write a ton of code.
So it's like polymorphism is kind of everywhere once you start to think about it.
Yeah, it really is. It's one of those things that the more you understand it, the more you're going to see how useful it can be.
Okay, so I think we covered a lot of ground today. Maybe we should do a quick recap for our listener, just to make sure everyone is on the same page about all this polymorphism stuff.
Yeah, that's a good idea. So we started by talking about what polymorphism is, how it lets objects take on all these different forms.
Right.
Then we looked at the two main types, compile-time polymorphism, which is about overloading those methods, and then runtime polymorphism, which is focused on overwriting methods.
And we used your research on payment systems to see how those actually work in real life.
Right.
And we even found that tricky situation where people might try to overload methods just using the return type and how that doesn't work.
You're going to have those different parameter lists, right?
Yeah, exactly. And then we talked about like all the good stuff about polymorphism, how it makes your code flexible, reusable, and how it can grow with you. I think those were the three main points.
Yeah, I think you got it.
And we even got to see how this could be used not just in payments, but also in things like games or graphics, which is pretty cool, I think.
Yeah, for sure. I think the biggest thing to remember about polymorphism is that it's not just some fancy technical term, but it's really like this powerful tool that can make your code better, easier to work with, and ready for anything.
Totally agree. I guess now that you've got a really good handle on polymorphism, the challenge now is to think about how you can use this in your own projects. Do you think you could simplify some of your code?
Oh, definitely.
Or maybe make your application more flexible so you can easily add new features later on?
Yeah, there's all kinds of possibilities.
That's what I love about programming. There's always something new to learn and new ways to do things.
Yeah, absolutely. I think the key is to just keep experimenting, keep learning, and you'll be amazed at what you can build.
Thanks for joining us for this deep dive into the world of polymorphism. It was great to explore this topic with you.
Yeah, thanks for having me. It was fun.